Hello everyone, this is Professor Russo. I'm going to do a quick review of the Unit 7 review sheet. Again, the topic is learning how to graph different equations of lines, and there's two basically different equations of lines. So one is where the y is on one side of the equation and x is on the other. And the second one is where the x and the y are on the same side and it equals a constant. For an example, like y on the first one, y equals 3x plus 1. Okay, and the other one might be like 2x plus 4y equals 12. Okay, so there's two types. And the way we graph them is a little different. The first method, of course, we will talk about on the next page, which is mostly taking points and putting them in, substituting. Since points are x and y, we substitute into the x and y. But remember that when we have a graph, I'm going to just draw down below, lower right here, right? We can have some lines, and those lines can be coming in at any crazy angle they want to, okay? And each one of those guys has their own equation. And the points that lie on those lines, they are xy points. And that means that every x and every y that you substitute into the equation for that line should make the equation equal on the left as well as on the right. So the first question that they ask you is, given a line, you're trying to find various points on the line. But in this case, they're going to ask you, are these points, are they ordered pair, which means the points, which means the x and the y's, okay? Are all the x's and y's on the line? That means they satisfy the equation. That means when you plug them in, it makes the equation true. For 3y plus 12x equals 3. So what you do when you see a question like that is you actually take the equation. I'm going to write it down here, 3x plus 3y plus 12x. And sometimes they mess around with you and they put the x first and the y second. This time the equation's got the y first. So we're going to remember that we're going to take each one of those points. So I'm going to take the first point and I'm going to plug it into that equation. So the first thing I see is the y, and my y is negative 3. So I got 3 times negative 3 plus 12, and my x turns out to be 1, so I'm going to put the 1 in there, and that's supposed to equal 3. So let's check it out. When I do my simplification, use your calculator if you're having trouble with those negative numbers. I get negative 9 plus 12. Yes, that is true. That equals 3 and that equals 3. Check. So that first point is on that line, 3y plus 2x. Right. Let's take a look at the next point. Okay. I'm going to take the equation again and always start with the original equation. Take a second. Write it over again. Look at your next set of points. There's your x, there's your y. Let's go plug them in. So the y gets plugged in front of the x, and in front of the 3, or behind the 3. And I got an x that's going to go here, right? And I'm going to put those values in. So the y is 13, and the x is negative 3. When I multiply that, I got 39. When I multiply this, I get 36 minus equals 3. That one is also true, right? And let's check the next one out, which does not work, okay? So we've got first 2 points. Those first 2 points there that I'm circling in red are on the line, and I will tell you that you should also get that this point, 5, negative 19, is not on the line, And the other guys that I left blank, I'll put a little blue slash mark through very lightly. Those guys will not be true. And I'll just double check this one here. Let's make sure that we realize that that one is not true. So I start with 3y plus 12x equals 3. And I'm going to plug in the x and the y values. And so when I plug that in, I've got, big number there, 32 for the y, 32 for the y. I'll need my calculator, right? And negative 7 for the x. And I get 64 minus 84. Well, that's a negative 20. That sure is not equal to 3. So therefore, that one is false. All right, so you can find out which points are on the line by substituting the x's and y's into the equations. Okay, let's go to the next page. Okay, this question is saying, can you graph the line? Okay, and we're going to use the graphing tool, which is down here. Okay, and you actually click on that and find 2 points. You notice when you look at that very closely, you only need 2 points. Now they're asking you in this question to get a bunch, aren't they? They're asking you, ordered pair means points. Look how many they want. 1, 2, 3, 4, 5. So you want to use points that fall on that grid and grab 2 that are nice and convenient. So here's what we sometimes write this. Okay, we actually, in the old days, before we had a nice fancy dancy table like we see up above, we'd have the x listed, and if you notice, here's our x's, right? Negative 2, negative 1, 0. Negative 2, negative 1, 0, 1, 2. So they really want you to plug in the x's, right, to see what the y's are. And then put the x and y together to make a point. So look at the first one. We've got negative 2. We've got to substitute into our equation. And again, notice this equation. I unfortunately, just quickly look at the top, right? Notice that we have the x on one side and the y on the other side, okay? So that makes this question pretty easy because when you plug in the x, it's going to tell you y equals that result. So I'm going to just take y equals negative 6x minus 1, and I'm going to take the first point, which is negative 2, right? Negative 2 here, and I'm going to plug it in where I see the x, always with a parenthesis so you don't mess up your signs. So y is supposed to equal this calculation. So here I get 12 minus 1. So y turns out to be equal to 11. So I'm going to take that 11, right, to get the answer right when you're doing it in My Open Math, the homework or the test. Take the y. It's looking for 11 up in the table here. Okay, so bring it up in there. Okay. Then it wants you to label the point, negative 2, 11. Okay, let's just not worry about graphing yet. Let's just get all these points labeled. So the next one I'm going to go, start back into my equation. You see, this is a lot of substituting into equations and finding things. That's what this unit's all about. So I'm going to substitute. The next one is negative 1 on the table. So I put negative 1 on that table that they give us. They gave us half the table. They give us the x's, and we got to find the y's. And when I do that one, let's see what I get here. There's a negative in front of that 6. Silly me. See how you can mess up on that sign. So this turns out to be 6 positive minus 1. Okay. And so that turns out to be, when I put in a negative 1, that turns out to be a 5. So negative 1 gives me 5. And I'm going to do 0. And 0 is an important one. Make a little room. Okay. Oh, So let's just plug in 0 and we'll go to the next one. So I got y equals negative 6x minus 1. Now remember, remember some stuff we learned about x-intercepts and y-intercepts that are coming up on the next page, that when you plug in x 0, we get a special condition. We get the y, or the vertical intercept. So let's do that. Negative 6 times 0 minus 1. And we get y equals 0 minus 1, which is negative 1. Let's go plug it in the table. Let's go bring it up to the top. So we're coming up with negative 1. Oops, not there. We said 0 gives us negative 1. Remember the 5. Okay, silly me. Let me fix this. Okay, hold on. All right, so we said 0. Let's do it in red. So 0 for the x right there was what we substituted in, gave us negative 1 for the y. Now, let's put those points in there, okay? Let's go to the right and fill in the ordered pair. I didn't even do it where I had the negative 1, 5, and now let's do our 0, negative 1, okay? And I'm going to give you the other values, okay? 1 is going to be negative 7, so the point is 1, negative 7. And when I put in 2, I get negative 13. So the point is 2, negative 13. Now, I got to go take these points, and I got to go plot them on my table. So I'm going to start, and I'm going to say, wait a minute. My table only goes as high as positive 10 and low as negative 10 on the y, and the same on the x. So I'm going to try to use my plotting tool, but I can't show negative 2, 11. But let me go to the next point. Negative 1, 11. Negative 1, 5. Negative 1, 5. It's up there. Let me make it look a little prettier. Get rid of that messiness there. Okay. And the next one is 0, negative 1. And the next one is 1, negative 7. 1, negative 7. And we could see that if I did take my graphing tool, I'd be able to draw that line right through there. Okay. So that's how you graph a line when you have the y and the x on the opposite sides. So when you plug in, as you see, when we plug in down below here, we automatically get the y equals, and we can plug that y straight in, take the point, plot a couple, use your tool. You only need to plot 2, by the way. I plotted all 3. You only need to plot 2. Let's go to the next page. On this page, you can say, well, it's the same question. Well, it is the same question. They're giving you an equation. We got to find the x's and y's. Except notice this equation has the x's on and the y's on the same side. That's different than the previous question. So that means we have to solve a little bit more. Okay? We're going to substitute and solve. And the solving is going to involve how to solve equations from the previous unit. So I'm going to do a couple questions. And this problem is the one that I'm hearing from most students. I will also send a hard copy out for answers if you need that. But I'm going to get through a couple of these here to kind of clarify, and I want to make sure my video doesn't get too long. So we're back to the same thing. Notice they're giving us the x's. We got to find the y's, and then we label the points, and then we'll go plot a couple. So as I did before, I started with the equation. I'm going to need that equation a couple times. So to get started, I'm going to plug the x in. Well, let me clean it up. Oh, it doesn't like that. X equals negative 18. So I'm going to start by taking that negative 2 and, like almost the last question, start plugging away. So I got 6y minus 18, there's my negative 2, equals negative 18 on the right. So when I multiply that out, I get a positive 36. And you see, I don't get the y directly now. I have to work to get that y. Remember, I'm trying to get this y by itself here, okay? So you remember, I got to get rid of all the other stuff that's next to it in the right order that we learned how to solve equations. So I got to take away 36. I got 6y equals, that turns out to be a negative 54. And then I divide by 6. And I get y equals negative 9. So you look at all the work it took to get that y. So my y turns out to be negative 9. And the point is negative 2, negative 9. And we'll be able to plot that one because we go as high as low as 10. We'll be good. We won't have anything off the charts, as we should say. And now we start and take negative 1. So I'm going to start in the equation again. Right. I'm going to get 6y minus 18x equals negative 18, and the x is negative 1. Okay, so when I plug that in, I'm going to get 6y plus 18 equals negative 18. I've got to get the y by itself. I got to take away 18 from both sides. I get 6y equals negative 36. Divide by 6. Y equals negative 6. So negative 1, negative 6, negative 1, negative 6. And we do 0. I like 0 because 0 makes things easy, and then we'll plot. And I'll give you the rest of them. So I start with 6y minus 18x again equals negative 18. A lot of work, a lot of paperwork, right? And I'm going to plug in 0 where the x is. So the x is going to be 0. I got 6y minus 18x equals negative 18. We like that because this calculation right over here is 0. So it's like it's not there. I got 6y minus 0 equals negative 18, which means I have 6y equals negative 18, so y equals negative 3. So I'm going to plug that in at the top. So 0 gives me negative 3, and the point up at the top there in the table is 0, negative 3, and I'm going to give you the others so that you have the answers. And when it's time to plot, you're going to plot those points. You're only going to need to plot 2, so pick some nice, easy ones, right? So I'm going to plot these 2. I'll put them in green. I like those 2 because they're the x-intercept and the y-intercept. 0, negative 3 is the y-intercept, or the vertical intercept, as we call it in this course. And the other one, I'll label it. You don't have to, obviously, when you're doing the assessment. And the other one is 1, 0, okay? The other one, we don't even have to graph. We're going to use our tool. And by the way, it's going to go through the point 2, 3. It's going to go through those other points. And so we should get a nice line that looks like that. Okay, let's go to the next question. So here we're talking about, I like the way they ask these questions because you see all those points we had to graph on those last couple problems. If I can just find those important points, those 2 that I graphed in the last question, the vertical intercept and the horizontal intercept. Okay. So the horizontal intercept is sometimes called the x-intercept, and you can see where I'm writing there in green, and the vertical intercept is sometimes called the y-intercept. Okay, and remember that in yellow highlighter, the horizontal intercept occurs and can be found when the y is equal to 0. So the y is equal to 0, and we go find the x. In the vertical intercept, or the y-intercept, it's just the opposite. It can be found where the x is always equal to 0, and we go find the y. And if we have those 2 points, I don't need to go get a whole bunch of other ones like in those last 2 questions. So you're going to be asked on the last couple questions of the test to here's an equation, go graph it. Now, how would you go graph it? I would start by making my life nice and easy, and I would get the vertical intercept, and over here, you notice to the right, I'm going to write the horizontal intercept. Because when I let the x equal to 0, I'm solving for the y, like I just had up there at the highlighter. That's going to give me the vertical intercept. So watch how easy that is. I'm going to take the equation y equals 3x plus 6, and I'm going to let x go to 0. Watch how fast we get that. 3 times 0 is 0, so y equals 3. So the name of that point, what did I do? I let x be equal to 0, right? And then I found the y as being 6. I have 1 point. And it's the vertical intercept. Okay. So let's graph it before I go to the next one. See where it is over here? 0 means no move horizontally. There it is, 0, positive 6. To find the horizontal intercept, I do the opposite. I take my equation, y equals 3x plus 6, and this time I substitute 0 where the y is. Now I got to do a little solving because I'm trying to find the x. And to do that, I want to bring my x over to the one side and keep my constants over to the other side. So I get negative 3x equals 6 divided by 3, x equals negative 2. So therefore, that point is another intercept at negative 2 for the x, comma 0 for the y. That would be over here. I'm plotting it on the grid now, and you'll connect the dots with your tool, and you've got that picture. The next one, I got a couple questions here. Again, we're going to be given these equations now that have the x's and y's on the same side. There they are. Next problem underneath it, the x's and y's are on the same side and the constants on the right side. These are really easy to solve for. And we're going to get the x-intercept, or the horizontal intercept, and the y-intercept. So to do that, notice I laid them out for us. To get the horizontal intercept, right? That means we're going to let the, well, we're looking for the horizontal, that we're looking for the x. We're going to let the y equal 0. And here we're going to let the x equal 0. So watch how fast that goes. There's my equation, x plus 2y equals 4. So when I let the y go equal to 0, so when I put 0 in here for the y, again, notice that 2 times 0 is gone. It's 0. And I get x equals 4. Excuse me. That means the point is 4, comma 0. I already can plot that. 4, comma 0 is over there. 1 point down. All I need is one more, and I'm going to get the vertical intercept. I'm going to let the x go to 0. So once again, I start with the equation, and watch how fast it goes. We're going to let the x be equal to 0. And when I do that, this is goner. Swish it right out. So I got 2y equals 4, y equals 2. That means I have another point called 0, comma 2. 0, comma 2. I'm going to go graph that right over there. 0, comma 2. Connect the dots. I got my line. Same thing below. Let's do question number 2. I've got 2x minus 6y equals 6. I'll do it twice, once for the x-intercept, one for the y-intercept. So I'm going to let the y equal to 0 for the horizontal, and I'm going to let the x equal to 0 for the vertical. So coming back over here, I'm going to let the y equal 0. So you could see that whole second term is a goner again, isn't it? That is gone. So I get 2x equals 6, x equals 3. My point is 3, 0. I'll plot it. 3, 0. Okay. Y is 0. Good. Okay. And the next one, sorry, I was just making sure I did it right. Next one, I'm going to substitute the x equal to 0. So that x is equal to 0. And when I do that, that guy's gone again. I get negative 6y equals 6, y equals negative 1. My point is 0, negative 1. And that'll be my vertical intercept. And then I connect the dots. Okay, so you'll be asked a question or so on that. And so you're going to not make a table. A lot of teachers will say, oh, get about 5 or 6 points like we did on those other questions prior. Just get 2 points, the x-intercept and the y-intercept. One last statement. There's a couple of these on the test and in the homework. Sometimes you get these special cases where there is only an x equal in the equation, or there's only a y equal in the equation. Everything else we've done has always been something x plus something y. But we have 2 special cases, equations of lines that have just x equal or y equal. And you notice they're special in their graphs. Most of the equations that we've been graphing, right, we've got these lines coming down at different slanted angles, right? Look at all of them that we did. All slanted angles there. So we've got 2 special situations. X equals means we have a perfect vertical line, no slant, straight up and down, and it's at 3. Okay, so it is a vertical line, and the name of that line is x equal 3. You could see it there in red. And the way to remember vertical goes with x is I use a little cheat sheet here. Notice the letter X is composed of 2 V's. The V will help you remember the V for vertical. Okay, the other one says, well, what if I had an equation that was just y equals? Okay, when it's y equals, I get a horizontal line. If you notice, y equals is horizontal. On purpose, I'm trying to take, you see that y equals? If I reversed it and flipped it over and rotated it, I can make an h out of that y. That'll help you remember that it's a horizontal line. So at y equals negative 4, I have a horizontal line right there. So those are the 2 exceptions. So watch, when you see y equals, draw a horizontal line at that point. When you see x equals, draw a vertical line. Okay, hopefully that helps you, and I will see you next time.